Welcome to Recording 1B in our series on rational expressions for Unit 6, Chapter 6 of Mathematics 2200. We'll focus on equivalent rational expressions and simplifying rational expressions. Many fractions, we can simplify them to what we call lowest terms. Likewise, 12/16. If we think of this as 3 times 4, in other words, factor the 12 like 3 times 4 and the 16 like 4 times 4. They have a like factor in the top and the bottom that can be divided off. And so we are left with 3 times 1 over 4 times 1, which is just 3/4. Now we can do that hopefully a little bit more quickly than that in our head, but that's basically what goes on. Negative 14 over 35, we can think of that as the negative of 2 times 7 over 5 times 7. Again, the like factors can divide off. 7 divided by 7 is 1 over 1, so we are left with negative 2/5. Rational expressions can often be simplified in a similar manner. Here's one with a monomial numerator and a monomial denominator. Now we have to determine non-permissible values first of all, but realize that 20st squared has to equal 0. We have two possible variables that could be equal to 0. They are s equals 0 and t equals 0. If either one of those is 0, then the whole denominator works out to be 0. Now we divide our like factors. So I'm going to first of all factor the 20 as if it was 4 times 5. And then I have st squared. 5 divides into the 5 once. T goes into t once and into t squared t times. So we are left with 1 over 4st. The other part of this instruction that we are asked to do is to state the restriction on the variable. Well, in this case, it's on the variables. So we've got our restrictions. Remember, if the non-permissible values are s equals 0 and t equals 0, then our restrictions are s cannot be equal to 0 and t cannot be equal to 0. On to example 2, the plot thickens. Simplify a rational expression with a binomial and or a trinomial denominator, or both. So let's see, the instruction here says factor the numerator and the denominator. Let's do that. The numerator here factors as x plus 11, x plus 1. The denominator has a common factor of x outside of x plus 11. We determine the non-permissible values by making the denominator equal 0. So x outside of x plus 11 is equal to 0. So x equals 0 or x equals negative 11. So those are the non-permissible values. Divide the like factors. Okay, so let's do that. We have x plus 11 times x plus 1 over x outside of x plus 11. The like factors are x plus 11. They divide into each other to give 1. So our final answer here is x plus 1 over x. So I'll write that up here. X plus 1 over x. We state our restrictions based on our non-permissible values. X cannot be 0 or negative 11. Take note of this little thought bubble. The simplified expression is equivalent to the original expression only if we use the same restrictions. So we've simplified, but we still cannot use the 0 or the negative 11. If we couldn't put them in the original expression, we're not allowed to put them in now. Now, before we really start this example, let's have a look at this idea. If I have something like 2 minus 5 over 5 minus 2, The result of that division is actually negative 1, because we'll get negative 3 over 3 equals negative 1. Likewise, if I have 2 minus x over x minus 2, we'll get negative 1. Let's see how that works. We take out a common factor of negative 1 from the top. So I'll reverse the order of those terms first. Take out negative 1 outside of x minus 2 now, over x minus 2. These factors can cancel or divide to give 1. I have negative 1 times 1, which is negative 1. So let's bear that in mind as we do this example. We factored the numerator and the denominator, so the top is the difference of two perfect squares, so it becomes 2 minus x, 2 plus x, all over 2x plus 3 times x minus 2. Now, we can already see where the x minus 2 will divide into the 2 minus x to give us negative 1 in a moment. But first we need to determine our non-permissible values. We set our denominator equal to 0 and make each factor equal to 0. So I'll do that crossways this time to give us a little bit more room here. 2x plus 3 equals 0, or x minus 2 equals 0. The second one's pretty straightforward, x equals 2. The first one takes a little bit more switching around. 2x equals negative 3. So x equals negative 3 over 2. Now we divide our like factors, and the only ones we have in this case are the x minus 2 and the 2 minus x, except they give us negative 1 instead of the normal 1. So we have negative 1 times 2 plus x. That's negative 2 minus x over 2x plus 3. And our restrictions are x cannot be negative 3 over 2 or 2. In summary, rational expressions can be simplified in a manner similar to simplifying fractions. Two rational expressions are equivalent only if one can be simplified to the other and if they use the same restrictions on the variable. And once again, review the steps here for simplifying.